So now we're going to go ahead and start answering the rest of these questions. I broke it up into two different videos. So the next set of questions we're going to do are the question number 5, and that is evaluate without using a calculator. And the first one that you were given is 49 to the 1/2 power. All right, there's a few ways that you can do this. I'm just only going to do one way, and if you do the other, that's perfectly fine. You can do it any way that you want. You don't have to follow what I'm doing here. But I'm going to go ahead and rewrite this as a radical. And remember, that rational power is saying power over index. So I'm going to first rewrite my radical sign. Our base is a number that goes on the inside. Our power is what the entire thing is being raised to. So it's being raised to the first power. You can write that out here like this, or you can write it next to the 49. And then the 2 is the index. So the 2 is what root we're taking. So remember, you don't have to put the 2. You could just have left that blank like this because it's understood to be 2, but let's just write it just so you know exactly where the numbers are going. And all this is saying here is what's the square root of 49? And the square root of 49 is 7. All right, that is it for this one. All right, now the next question said 125 raised to the 4/3 power. All right, so same thing. We're going to rewrite this as a radical. So I'm going to first rewrite my radical sign. Our base is a number that goes on the inside, so it's 125. Remember, it's power over index, so this is being raised to the 4th power. And our index, or the root that we're taking, is 3. Right? The reason why I keep writing these numbers on the outside like this here is because whenever you're doing this without a calculator, it's easier for you to take the root first, because then we break the number down to a smaller number. You wouldn't know what 125 to the raised to the 4th power is off the top of your head. So it would be a little bit harder for you to do that. However, you should know what the cubed root of 125 is. That's saying what number times itself 3 times is equal to 125. Well, 5 times 5 is equal to 25. 25 times 5. 25 times 5 is equal to 125. So 5 times itself 3 times is equal to 125. So the cubed root of 125 is 5. And now we're left with 5 to the 4th power. So we want to evaluate. So it doesn't say leave it as a prime number raised to a base. It says evaluate. So we must evaluate this. Well, we know that 5 cubed was 125. So we just need to multiply this one more 5. So this will then give us 625. So 5 to the 4th power is 625, and that would be your final answer. Right, now the last question for this section was 27 raised to the negative 2/3 power. Now this one, a lot of people are having trouble with because of this negative power. Remember, the first thing you want to do is you want to make that positive. So all this is saying is this is equal to 1 over 27 to the 2/3 power. If you want to make your exponent positive, you take its reciprocal. Remember, you say you're loving me, but now you're flipping like reciprocals. So you take its reciprocal. So since this is first written in the numerator, it needs to drop to the denominator. Right? So now we're going to go ahead and rewrite this using a radical. So it's 1 over, I'm going to put the radical sign. The base is a number that goes on the inside. Our power, remember, it's power over index, so our power is 2, so this is being squared. And our index is 3. Remember, the reason why we're doing this is because it's easier for us to take the root of a number than it is to square these numbers. So the cubed root of 27, well, 3 times 3 times 3 is equal to 27. So this is saying what number times itself 3 times? It's 27. And that is 3. So the cubed root of 27 is 3. So this is equal to 1 over 3 squared. Once again, we're asked to evaluate. Well, 3 squared is 9, so it becomes 1 over 9. Right? A lot of people in class wanted to go ahead and make this a negative number because it had a negative exponent to begin with. But remember, just because this is negative, it doesn't actually make your number negative. It's saying that we need to take its reciprocal. Right? That is it for this number 5. All right, so the directions for this one said write with a prime number base. So remember one of the last few questions that we did was 5 raised to the 4th power. If these are our directions, then this is how we would leave our final answer, because it's saying write it as a prime number base. So meaning we want a prime number being raised to a power, right? So depending on how we write our answers is whether or not, or depending on the directions is whether or not we will multiply this or evaluate. Remember, the last one said evaluate, which is why we had to rewrite that as 625. Right, so this first question said 25 to the x power over top of 125. So since we have an exponent here, we can't just simplify 25 over 125 and say that's our final answer, but that's what a lot of you were trying to do. But once we have an exponent, we need to use our exponent or index laws. So in order to do that, we need to first have a same base. So this number being raised to the power needs to be the same as the other number raised to a power. And even though no power is written there, it's understood to be 1. So we need to have them the same. So we're looking, can we rewrite 25 and 125 as a prime number raised to a power? Well, we know that 5 squared is equal to 25, and we know that 5 cubed is equal to 125. So I'm going to go ahead and substitute 5 squared in for my 25, so it gives me 5 squared. But remember, this 25 was being raised to the x power, so you cannot forget about that. A lot of you were in class. 125 is equal to 5 to the third power. Our rule with power to a power is we multiply. A lot of you guys were adding these and saying 2 plus x, but we multiply. So that means this numerator is equal to 5 to the 2x power. So 25 to the x power is the same as 5 to the 2x power. They are the same thing, just written in a different way. Now that we do have the same base, we can just use our index laws. And our index laws say that we subtract our powers when we're dividing. So this will then become 5 to the 2x minus 3 power. And since there's nothing that we can simplify with this 2x minus 3, this is just our final answer. All right, the next question said 49 to the k plus 3 power over top of 7 to the k minus 1 power. So the same thing as the one before, where we had 25 over 125, where we needed to rewrite it as a prime number raised to a power. We have to do that here too, but the difference is this one is already already a prime number raised to a power, so we don't have to simplify the denominator at all, but we do have to go ahead and simplify this 49. And since this one's already written as a 7, we know that this 49 will need to be expressed as 7 raised to some power. And 7 squared is equal to 49. So that means we can go ahead and rewrite 7 squared where 49 is. So this is equal to 7 squared, and it's still being raised to the k plus 3 power. Now, a lot of you guys were having trouble with this one as well. Remember, power to a power, we multiplied. So this 2 needs to be not only multiplied to the k, but to the 3 too, because there's 2 terms here and 1 here, so we need to multiply both. We need to distribute that 2 in. So this 7 squared raised to the k plus 3 power is the same as 7 to the 2k plus 6 power. And that's all over top of 7 to the k minus 1 power. Right now, another thing that you guys are having trouble with, we now have the same base, so we can go ahead and use our index laws, but this is saying we need to subtract both the k and the minus 1. So this is equivalent to 7 to the 2k plus 6 power minus, or let me do this off to the side rather than doing it in the power like that. Right? So this is saying 7 to the 2k plus 6 minus k minus 1, so we need to do 2k plus 6 minus k minus 1. So you were getting this first part correct, where it was 2k minus k, and you were getting k. You were all getting that. The thing, though, that you guys were doing is you were saying 6 minus 1 is equal to 5, but that's incorrect because it's minus a negative 1. So we need to change this to 6 plus 1, which is equal to 7. So this was actually k plus 7. So the final answer for this one, let me write it down. Write it over here. It's 7 to the k plus 7 power. That was your final answer. A lot of you were saying k plus 5 power because you were doing 6 minus 1. But remember, we're subtracting it. We're subtracting both of these, the k and the minus 1. So the subtracting k is 2k minus k. But when we subtract the negative 1, it needs to turn to 6 plus 1. All right, one more in this section. All right, now the last question for this one was 8 times the square root of 32. All right, a lot of you, when you were writing this, you were writing this as your problem, the 8th root of 32, and that's incorrect. Remember, if it's written big like this, it's saying we're multiplying them, right? So since we want a prime number base, we need to go ahead and rewrite these. So we can rewrite 8 as 2 cubed. We know that 2 raised to the third power is equal to 8, so I'm going to go ahead and rewrite this 8 as 2 cubed. So it's 2 cubed times. So now we need to rewrite the square root of 32. So we know our base is 32. There's no power written with any of this, so it's understood to be 1. And then when there's no index written, it's understood to be 2. So this is now saying 2 to the third power times 32 to the 1/2 power, right? But the problem with this is these bases are not the same, so we can't do anything. However, we can rewrite 32 as 2 to some power. And what is that? 2 to the 5th power is equal to 32. Now, if you're not sure, since this is already written as a prime number for us, we know it has to be a base of 2. Just off to the side, just do 2 times 2, that's 4 times 2, that's 8 times 2, that's 16 times 2, and that's 32, the number that we want. And we multiplied 1, 2, 3, 4, 5 2's together. All right, so if you're not sure, you can always do that off to the side. So this now is equal to 2 to the third power times 2 to the 5th, and that's still being raised to the 1/2 power. So our rule with power to a power is we multiply. So this will then give us 2 cubed times 2 to the 5/2 power, because 5 times 1/2, well, this is 5 over 1. We multiply our top with our top, our numerator with our numerator, and our bottom with our bottom, denominator with our denominator, and it's 5 over 2. Right, now that we have the same base, we can go ahead and use our index laws, which is telling us to add our powers. So we will then, off to the side over here, let's do this in green. We need to do 3 plus 5 over 2. Let me just write this a little bit off to the side. So 3 plus 5 over 2. Well, in order to add fractions, we need to have the same denominator. So we need this 3 to be over top of a 2. So we need to multiply it by 2 over 2, because 2 over 2 is 1. We're not changing any value. So it's 6 over 2 plus 5 over 2. 6 over 2 is still equivalent to 3, but we'll just rewrote it in a better way for us so we can actually solve this. So our base remains the same, and now we do 6 plus 5, which is 11, and our denominator was 2. So that was your final answer. All right, that was it for section 6, and there was one more for us to do. All right, so for this last problem, it said, in this study of 50 people, it was found that 40 have blonde hair, blue eyes, or blonde hair or blue eyes. 15 have blue eyes, and 32 have blonde hair. So that, and it asks us to find how many have both, how many have neither, and how many have just blue eyes. So this 40 people have blonde hair or blue eyes. That means that they fill up every single section of this circle, because they either have blonde hair or they have blue eyes. So every single 1, 2, 3 regions are going to add up to 40. So that means that those 40 people have to have blue eyes or brown hair. So 15 have blue eyes. So if we take that 40 and we subtract 15 from it, because we know 40 100% have to have one or the other, and if 15 have blue eyes, that means the other ones must have blonde hair. So 40 minus 15 is 25. So that means that there's 25 people who only have blonde hair, because these 40 have to have one or the other. And if only 15 have blue, that means the remaining of these 40 must have blonde hair, because 40 people have blonde hair or blue eyes. So once we know that there's 25 that have blonde hair, and there's 32 total, so that means in this entire circle, there's 32 people. Well, we've already accounted for 25 here. That means the remaining of those 32 have to be put in this region. So we can then do 32 that have a total of blonde hair, minus the 25 that have only blonde hair, and that's equal to 7. So that means 7 people have both. All right, so then the last part with blue, we have 15 people in total that have blue eyes. So that means this entire circle needs to have 15 total people in it. Well, we've already accounted for 7 here, so that means the remainder of the 15 must only have blue eyes. So we could do 15 minus 7, and that's 8. So that means those 8 only have blue eyes. And there's 50 people in this entire study. 40 have blonde hair or blue eyes. So how many people have neither? We're going in this outside box. That would be 50 minus 40. So that means 10 of those people had neither blonde hair or blue eyes. So now let's use this Venn diagram to go ahead and solve A, B, and C. So how many have both? Well, the amount to have both is the one that's involved in both circles, where both circles overlap. So that is this 7. So there are 7 people that have both. How many have neither? So neither is the outside of the 2 circles. So that are these 10 people here. So then we can go ahead and say that there are 10 people that have neither. And how many have just blue eyes? Well, the ones that have just blue eyes are the ones that are just in this region of the circle that's not overlapped with our blonde hair circle. So that has to be the 8 people that have just blue eyes. Right, so that was all the questions that we did in review. There's just one other thing I want to go over with you guys real quick, and that'll be it for this video. But remember, if you have any questions, please reach out on Remind. I know I went through these kind of quickly, but I just wanted to get all the information out there for you. So not only did you do it in class, but you can watch the video if you need to as well. All right, I just want to go over all of our index laws again with you one more time. So remember, if we are multiplying with like bases, we need to go ahead and add our powers. If we are dividing with like bases, which is what we're doing here, we need to go ahead and subtract our powers. If we are raising a power to a power, we have to multiply them. If we have multiple items within that parentheses, then this power needs to be distributed to both, and both of those powers would have to be multiplied. So it's still a power to a power. Same thing, even if it's division. If we have power to a power, if we have a division and it's all being raised to a power, everything gets raised to that power. Anything raised to 0, no matter what it is always equal to 1. The only thing is that a cannot be 0. 0 to 0 power, you'll find out, is indeterminate form. And then anytime we have a negative power, if we want to make it positive, we need to take its reciprocal. So if it's in our numerator to begin with, it gets written in our denominator. And if it's in our denominator, it will get written in our numerator. Right? So these are all the powers, or all the index laws that you will need to know. So just make sure that you are studying this page along with all the questions that we just went through.